What you're going to be looking at today is classifying real numbers. You have classified real numbers before, and so this is going to be something that is not completely new to you. So, on classifying real numbers, we're going to look at this example first because it's more of a realistic example to kind of help you understand what's going on, and then we're going to look at a actual example using the correct terminology. So it says, over the summer, Ethan spent a week at camp. Ethan met several campers, including those from different states, to those that ended up being in some of Ethan's classes at school. The categories listed below describe the type of campers that Ethan met in no particular order. Use the graphing organizer to place the letter of each category where you think it might belong. So if we want to look at the most specific category that affects Ethan, is we probably are thinking that the people that are most specific to Ethan are the people that are in the same class as him, right? That's our smallest group of people that we're going to be involved in. So the smallest group is probably going to be the group there in the middle. Then, if we're looking at these things, what would be the next, in your head, if you were to think, what would be the next thing that would, as we worked out, that would be associated to the same class? Probably the same school. And then once we move, so we've used the same class, we've used the same school, and then as we continue to move out, we have the same city, and then we have the same state. Then we have this other little piece over here that is out of state. That is something that is not directly related to what is happening in Ethan's little bubble, right? So the people that, or the category that's over here would be the people that are out of state. Now it said Ryan is one of Ethan's camp friends who is also in his first period class. List all of the sections of the graphic organizer that Ryan's name could belong in. So obviously, Ryan is in his first period class, so we know for sure that he falls in B. If he's in his first period class, does that mean that he also lives or goes to the same school? So does he also, if he lives in the same class, wouldn't he have to go to the same school? Oopsie, didn't mean to do that. Same school. And then wouldn't they live in the same city at that point? And wouldn't they also live in the same state? However, would Ryan live out of state? Probably not. So he doesn't fall in that category over there, E. It says, which would be the best section to place Ryan's name in? And it would probably be the same class. Now we can start thinking about that when it comes to numbers. In this set of natural, whole, integers, rational, and irrational. So let's first define what each one of these are. So the set of all positive counting numbers. So this is, if you think about it kind of like in relation to school, when you were first learning how to count, you started counting with 1, right? So you started with 1. Examples of real numbers that you may see would be, for example, 24. You may see it written as 50 over 2, because if you were to do 50 divided by 2, it would give you 25. And you may see the square root of 81, because that's 9. They all end up giving you a plain old whole number. They are not parts, they're not anything like that. It's just a plain or natural number. It's just what you would learn when you started counting. And then you went to school, and they added on 0. So it kind of like went 0, 1, 2, 3. And some of the things that you may see with that are, if you see 15 over 3, because that simplifies down to 5, you may see 0, or you may see the square root of 9. And then you continued on in school, and they taught you about the other side of the number line, and it is a set of whole numbers and their opposites. So you may see negative 12 over 4, because that would simplify down to negative 3. You may see 5. Or you may see the negative square root of 64, because that would be like negative 8. And then you continued on in school, and they taught you about rational numbers. They're numbers that can be written as fractions, terminating decimals, repeating decimals, and perfect squares. And so you may see some examples of this as the square root of 16, negative 6.5, 0.33 repeating, or 1/2. And now you come to us. You come to 8th grade, and we start teaching you about irrational numbers. So when you are thinking about irrational numbers, these are the numbers that cannot be written as fractions. They are non-terminating decimals, non-repeating decimals, and they are non-perfect squares. Now, one of those numbers that you probably don't think about, but you have been using for a long time, specifically a lot in 7th grade, was pi. And if you remember, your teachers always told you to round pi, because round pi goes on forever and ever and ever, and it never ends. Another example that you may see like that is like 3 pi, because if you multiply anything times pi, it gives you a not perfect number. It could be the square root of 18, because it's not a perfect square, the square root of 42, just for some examples. And then I'm going to add a new page in here. Maybe not. Why can't I add a page? Paper. Well, we'll do a sticky note, and I'll show you on a sticky note. So, I'm going to show you an example of how this works. Maybe. Doesn't want to. There we go. I'm going to show you on a sticky note how this works for the real number sets. So if you are going to have a system that is a box that looks like this as real number sets. It's going to have a part over here. And inside of this box, you are going to have a smaller box, and then a bigger box, and then an even bigger box. So these are real numbers. Just kind of exactly like this other one that you just saw, right? The boxes kind of look the same. So within this smallest box is going to be your whole numbers. Or I'm sorry, your natural numbers. And that is like your 0 or your 1. Sorry, remember we don't start at 0. 1, 2, and so and so. And then you have your whole numbers. And then you have your integers. And then you have your rational numbers. And on this other side over here, that is still part of the real number set, but it's not part of this rational number box, is your irrational numbers. Now, I want to talk about, earlier it said which section would Ryan most fit in. I want to talk about how this works whenever it comes to labeling numbers. So if I gave you a -5, -5 would fit best into integers, right? It would be an integer. It would also, however, be a rational number because it sits inside this rational number box. But if you look at it, so this -5 sits inside the rational number box and it sits inside the real number box. It does not have any relationship with the irrational numbers. And I can't put it inside the whole numbers box. So this -5 can work its way out So if I show you in a different color, it can work its way out, but it cannot work its way in. So it would continue. So on here would be an integer, a rational number, and a real number. If I said a half, 1/2 would fall into rational numbers. It would be a rational number. And it would be a real number because I can work my way out, but I cannot work my way in. If I use the square root of 21, the square root of 21 falls over here. So it would be an irrational number, and it would be a real number. It can't go to the other side of the box over there because of this line right here. It gives it kind of a breaking point where it can't be the same. Okay, so what you're going to do here in a little bit is you are going to go and practice in Schoology. There is a practice paper for you to practice, which we are taking it as a grade, so make sure that you do it.